Sikole ngambulo luku. With whatever we do. Jioni safu no la. With whatever we do. Hale yide munyu skula. Nyepamne kudlukula. Nyepangi ragala gena. Nyepamne kudlukula. Ibuloke nongoto ni beti sola. Ibuloke dato ni betoto.
Bege Congo.
Lamin.
Na?
Lamin te jibe norin te nyame Lamin.
Kabona wulo kono.
Wulo kono nyinta mo Lamin.
Fabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Babanyola.
No ngoto le Fabrama.
Na mu jumala kan kuma diten.
Fabrama.
Jumala mu.
Ndele bare muso.
Lunda mana. Jamani mbere.
Lindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na ramudu wa kontan.
Ngoto minaka ngala min de fon filitala. Lamin ji nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko molla ko momo.
Ngoto.
Nam.
Itedin talo ne Lamin hakilo diata bake karamungot. Anu santeng ministry ko di ngole si suko na amanke ko do holiday. Sibitu. Ala ni ko kede namo balo.
Ala ni na ko na karta bulo be dam ala ni je.
Ngoto.
Nam.
Ngoto mon kontan fere.
Jamani mu ne keda.
Ifika Lamin ki wulo ko no nyinta mon ko do fete malo Lamin nyande sila la be la moy kala karango.
Jamani karamol be soron ne ko fasita wulo ko nako.
Baba.
Karamol ma soron. Ni ko karamol soron da amanke kom holiday. Ngoto. Dini wonyanta sila la ala karango la moy yamen kamen fue. Man kontan andamande.
Allah nyin kombo kurang adanda la kombo len do la jankara mol soron doro kamen kurang mara do la kombo e kondol fana na kara mol soron je kara mol soron Lamin ada lo nyi la amanta rafe na sokon ala munekela
Lamin ite foyde malon ko lesinol be ke kar radio to
Nga fine.
e ko nyani mo Lamin
Nga fine.
ya mo na fonye
bi kabin mina kan tambita nteri maning Fatu
ha
tambite la sola dini wol bebe si moy ka
faru dan so am fana tambita jele ni subala la ngaje dini ngol be jet talanta nen kili waro e be serin jelet
sa Lamin farante ku kili wo ke no la ba Lamin bita ka wulo ko no nyinta mo Lamin
amanta rafe na la
ite dine ko di man si yakaru lesinol la moy radio to e balon na
muneka ke afonde ba nyaama ndi alon
telente jikot
afonde ba mu be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa mala ya itarije
nyarande kombo kurang ho findira kombo ida jede ko Lamin manya tala wulo ko ka mo be so da fa membe
ko to wole nati bawo ngalle ni Lamin kunta kombo kurang o ka fa me kombo kurang asotota ne ko esi suwo kono bari ni ko esi suwo kono be karangol dike la radio lin telel to hani tele to nyaay man tele soto la bo bar radio be bulen koto batiri sanga ay si ay alamo
sa do ka nyaadi ado ka nyaadi
kamun ke nyaadi
radio abe wala moy la be mona falaje
ibe la karandirol kala jele
ti talle be radio
ila subjector baby jele baby jele
wala nanga chocho moy fa dan so wala ngombe tambi kana ngadi ni ngol be ikadum bungo de ko kada ma
asotota
wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko nde ko folle sinila mba ndele sinilo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yu fana bulata ko ko me yen nati jambi Lamin nyanta karana ntel beji ko be nyineka ya bulay kar wulo kono ta kilar ya bambalo yo be bulaje dindi ngoy si ala le la mo radio
wala ka kara sponsor Lamin nyanta kara si so na radio la
sila le ala si do
korno kosmo
kilar
ngala ko
Thank you bro
ndaba ko la da barro sa no radio ba no bari woro radio ni abe jele ba ngamra do man dembe buljan dala nyara nyar wofra bu ko fendi mo la Lamin tayra barro sa
bara te ku folo nori na Lamin tamete ku
mingi mun na re
teku
bari ko do famo ke
ema nani nyambol si zol le keje kisigi man si zol no le kafun ka nyoma bari nyambu kilo ni manya na kafindi ni nambe ko zol la ga
ngalle limbeta de be nyambo do dilanna
nyara ni ko rin fennat nyara nata
bari famo keda
ngata bungono tambi bungono nyara ngando ko fele ko ke baru nganda ni pelo landi jak
iyo awe betar la
bungono bismillah bisu diara
pendulala yefungo tanka sina dolu tanka koro korota korota
Hello viewers and wonderful listeners out there. Welcome to another mathematics lesson for the senior secondary school category. Remember, it's your teacher, Mr. Mas Jame. The lesson is still bearing. Today we are going to continue from where we stopped in our last lesson. In our last lesson, I gave you an assignment and we are going to take it from the assignment. Then we move to our lesson proper. The question that was given to you as an assignment was, students were asked to find the bearing of Z from Y, and the question given was, if the bearing of Y from Z is 315 degrees, find the bearing of Z from Y. So this was the question given to you to try. Can we look at it together, please? Now, the question reads, if the bearing of Y from Z is 315 degrees. I told you something the last time, that is, the location that comes immediately after the word from is what you take as your first point. Then with the bearing given will help you to locate the other point. So the location that comes after the word from is Z. So I will locate Z first. But looking at the bearing given, the bearing is 315 degrees. And if you look at 315 degrees, I told you something about the quadrants. 315 degrees is in the fourth quadrant. So it means we can start drawing from this point here. So we have something like this. So this is going to be point Z. And remember, I told you that all bearings must be measured from the north. So is Y from Z, so we take Z to locate Y on a bearing of 315 degrees. So it is going to be like this. So this movement here is 315 degrees. So it's Y from Z, so we are going to locate this point as Y. So if this is the diagram, what can you do to find the bearing of Z from Y? I gave you two rules again. I said if theta is greater than 180, what do? We subtract to get the reverse or back bearing. And if theta is less than 180, we add to get the reverse or back bearing. So if you look at the number 315 degrees, it is greater than 180. So in this case, we are going to subtract to get the back bearing. So the back bearing is going to be Z from Y is going to be equals to theta minus 180 degrees. So if you subtract this, you will have theta in the question is given as 315 degrees minus 180 degrees. So if you subtract these two numbers, you are going to get 135 degrees. So it means the bearing of Z from Y is going to be 135 degrees. I said the last time there is another way of doing it using the concepts of what? Angles. If you use the concept of angles, like we know that at this point is 270 degrees. If I subtract 315 minus 270, you are going to have 45 degrees. So if this angle is 45 degrees, this angle here will be 45. In the first quadrant is a right angle. So if you add 90 plus 45, that will give you 135. So this is the correction to the assignment, and I'm very sure some of you might got the answer correct. So for those who don't get the answer, this is the way to solve to get the answer to the question. Now we move to the lesson proper. For today's lesson, we are going to learn about distance bearing. Now this part of the lesson is very, very, very important, because if you look at most of the past questions that we solve, this is where students are normally attacked. And you need a greater or sound knowledge about this distance bearing for you to at least answer past questions when they come your way in exams. Now, there are certain things that I would like you to know about these distance problems. And what are these things? We said to solve distance problems on bearing, a proper understanding of the following is a must. I stress the word must because if you don't know those things, it will be very difficult for you to solve distance problems. Now, this includes the use of the Pythagoras theorem. In our previous lessons, you were taught how to use the Pythagoras theorems with seriousness. I remember fully. Also, you learn how to use trigonometric ratios to solve questions under triangles, and also you were taught how to use the sine and the cosine rule. So these three are very, very key. So if a student lacks a proper understanding of these 3 points, he or she will struggle to answer distance problems on bearing. And I know most of you are having those problems as I speak. All right? But with this lesson, I'm very, very sure we can try to make sure that we eradicate those fears that we have about the distance bearing. Now, this takes us to the first example. In the first example, Mr. Fanny traveled 30 kilometers on a bearing of 30 degrees. How far east has he traveled? I repeat, Mr. Fanny traveled 30 kilometers on a bearing of 30 degrees. How far east has he traveled? If you look at the question, it is self-analysis. It has already analyzed itself. You just need to make a proper sketch of the diagram, then get your triangle, and you can solve to get the answer. Can we do that together, please? The question is, Mr. Fanny traveled 30 kilometers, that's the distance he covered in his journey, on a bearing of 30 degrees. If you look at 30, is a number that is found in the first quadrant. How far east has he traveled? So we can make that sketch right away on the board. So since 30 is in the first quadrant, we can sketch the diagram here this way. Let's say this where we have Mr. Fanny. He traveled 30 kilometers on a bearing of 30 degrees. 30 is in the first quadrant. We estimate it to be some point around here. So we extend a line. Let's say the point he's traveling towards is called point A. So the distance from where he started to where he is going to is 30 kilometers. And it's on a bearing of how many degrees? Remember, all bearings are measured from the north in a clockwise direction. And that's going to give us 30 degrees. So if this is the bearing of his movement, we are asked how far east has he traveled. If you look at the 4 cardinal points, this is where we have the east. So it means he is moving towards the east. We have to make an extension. So in making the extension, I'm going to use this line pattern to show his movement. But also you have to know that this line is parallel to this other line. So as this one extends upwards, this one also could extend upward and downwards respectively. So you can also extend this the same way. So this gives us what? A right angle triangle, because when 2 lines or 2 perpendicular lines meet, they form what? A right angle. So if this is what you have, the next thing we can find out of the diagram is we can tell the value of this angle. How do we know the value of this angle? I told you earlier on that in each quadrant there is what? A right angle. So if this is 90 degrees in the first quadrant and part of the angle is given as 30, we can always subtract 90 minus 30, and that will give us how many? 60. So this angle here is going to be 60 degrees. So if this angle is 60 degrees, I want to label this point as, let's say, B. If this angle is 60 and the question is how far east has he traveled, so we are going to find the distance between Mr. Fane here and point B. So I want to label that distance as x kilometers. We don't know. So to know that, remember we are going to use the trig ratios. And what are these three ratios? The trig ratios are from the previous lesson. Remember we have so, we have ka, and then toa, given the acronym SOCA-TOA. So here, I want to find the value of x. I have to check among these three, which one can we take to get the answer right away. My aim is to know the value of x. This is our right angle, facing this side which is the hypotenuse. This is our angle, facing this side as the opposite. So it means we are calculating the adjacent. Knowing the hypotenuse and the adjacent with the angle given, you can always solve. Our adjacent is x, our hypotenuse is 30, and the angle is 60. So here we are going to use what? We are going to use ka, which is cos. So we are going to say cos 60 equals to adjacent is x all over the hypotenuse is 30. So if you simplify this by cross multiplying x times 1 is x equals to 30 cos 60. If you cross multiply this, what you are going to get. So in cross multiplying, remember cos 60 in your calculators will give you 0.5 or 1 over 2. All right. So x equals to 30 times 1 over 2 or 0.5. If you take half of 30, x will be equals to 15 kilometers. So this is the distance Mr. Fane traveled towards the east. I hope students will follow the way I did the solution on the board, and I think this will help. So when solving questions on the distance bearing, it is always ideal for students to make a sketch of the diagram, and also after doing the sketch proper, it will always help you to solve down to get the answer. Okay, example 2. Osman travels 4 meters on a bearing of north 50 degrees west, and Fatu travels 3 meters on a bearing of north 40 degrees east. What is the distance between Osman and Fatu? So if you read the question like I said, once you get the sense out of it, you can always analyze it and then do the interpretation on the board. Can we interpret the question together on the board? Now there are two key messages. North 50 degrees west, and we have north 40 degrees east. These are the two key messages. And the distance apart, or the distance traveled, is also given us 4 meters and 3 meters respectively. So we are going to make the sketch of the diagram. If you look at these numbers, the last time I told you something about the 8 cardinal points. Okay? So we are going to use that idea to make the sketch of this diagram. So we are going to sketch it this way. Let me move a little bit to the center. Let's say this is the 4 cardinal point, and this is where we have the north. The first value given, north 50 degrees west. This is our east. This is our west. So if I want to locate north 50 degrees west, it means measure 50 degrees from the north towards the west. So we are going to have that line here. How many meters did he travel? Osman traveled 4 meters. So we extend our line upwards like that to this point. Let the starting point be A, and the point he is moving towards be what? B. On a bearing of north 50 degrees west. Now we are told that Fatu travels 3 meters on a bearing of north 40 degrees east. This is the distance between the north and the east. That's the first quadrant. And the bearing is 40 degrees. So 40 degrees will be here. And the distance traveled is 3 meters. So the distance is less than Osman's distance. So we are going to extend a line to a point like this, and we may stop here. Let's label that point as C. So the distance traveled is 3 meters, and then the bearing is 40 degrees. Now, since this is what we have, the next thing we could do is to connect the points, and that will give us something like this. We have a triangle. Now, if you add 50 plus 40, that will give us how many? 90. So it means we have a right angle triangle. So at A is 90. Distance AB is 4 meters. Distance AC is 3 meters. The question is, what is the distance between Osman and Fatu? So if you look at the distance between Osman and Fatu, here we are not given any other angle at B or C. So this point is C. Now, if you look at the parts that we labeled, our target is to know the distance between what? Osman and Fatu, and that is line BC. How are we going to get line BC? Remember, in the previous lesson, you learned about the Pythagoras theorem. Okay, so that's exactly what we are going to use to get the answer. To use the Pythagoras theorem, I'll label this side as small a centimeters. Now, we are going to use the Pythagoras theorem to solve the length BC. And to remind you again about the Pythagoras theorem, it states that the hypotenuse squared, abbreviated, must be equals to the opposite square, abbreviated, plus the adjacent squared, also abbreviated. Now, where do we call the hypotenuse? Where do we call the opposite, and where do we call the adjacent in this diagram? You were told that the side opposite to the right angle is always your hypotenuse. And what is that side? The side opposite to the right angle is A. So we put A square in this case. We have the opposite and the adjacent. In this question, I said at B and C, there is no angle given. So it might be a bit difficult for you to determine which side is the opposite and which side is the adjacent. So here, in cases like this, you will never be penalized for taking any of them to be the opposite and the other being the adjacent. The reason is there is no angle given to give you a direction about which one should be the opposite and which one should be the adjacent. All right? And if you look at it again, since you are adding two squares, addition is always commutative. Okay? So in this case, you will have 4 squared plus 3 squared. A squared equals to 4 squared will give us 16 plus 3 squared will give us 9. A squared equals to 16 plus 9 will give us 25. Now, since we want to know the value of A, we take the square root of both sides. If you take the square root of both sides, the square will cancel the root. Now we are left with A equals to the square root of 25 is 5. Don't forget the units. The units given is in meters. So that will give us 5 meters. So this is going to be the distance between Osman and Fatu. Now we move to the next question. The next question is, a boy walked 6 kilometers from a point P to a point Q on a bearing of 65 degrees. He then walks to a point R, a distance of 13 kilometers on a bearing of 146 degrees. Roman 1, sketch the diagram of his movement. Roman 2, calculate correct to the nearest kilometer the distance PR. Now, before we sketch this diagram, I used to tell students most of these things in my presentations when I'm teaching in class. Bearing that regards 3 points, there is a pattern that you should always follow. The pattern of the diagrams are in different ways. The first way your diagram could be is it may open upwards like this. Take note, okay? Because among the 3 letters, there is always a letter that connects. And what is that letter? The letter that connects is always there. That can always cause the diagram to open upwards. So take note. In another way around, if it doesn't open upwards, it may open what? Downwards. All right? So when I mean open upwards, it may be like this. And if I mean open downwards, it might be like this. So you need to be very, very conscious about that. Because reading the question alone will tell you that this is the shape you're going to get. All right? Then, if it doesn't open upwards or downwards, what other ways do you think the diagram may open? It may open this way, which is in this format. Or it may also open that way, which is going to be this way. Where each of these are said to be what? Points given in the question. So I used to give those analysis to students, those who can read and understand and can always give the diagram as quickly as possible. Right away. So we start solving the question together and you see how it goes. A boy walked 6 kilometers from a point P to a point Q on a bearing of 65 degrees. He started from P to where? Q. So the bearing is 65. Remember 65 is in which quadrant? Is in the first quadrant. Take note. I read again. He then walks to a point R, a distance of 13 kilometers on a bearing of 146 degrees. Where do you have 146 degrees? Is in the second quadrant. Now we are going to sketch the diagram together. And in sketching the diagram, can we do it together, please? Now, he started from P on a bearing of 65 degrees. Okay? And we said 65 is in the first quadrant. So we are going to sketch the diagram here. So 65, the line may open up upwards. So you step down a bit so that you can make a proper sketch. So we start in here from P to a point what? Q on a bearing of 65 degrees. 65 is in the first quadrant. And the distance is 6 kilometers. Let me reuse the distance a bit. And the bearing was 65. We are told that he then walks, this is point Q, he then walks to a point R, that is from here, a distance of 13 kilometers on a bearing of 146. So 146 is in the second quadrant here. So we have to make sure that these two lines can never be equal because this one is 6 kilometers and the other one is 13 kilometers. So this line will be a bit longer. Okay, so the bearing is 146 degrees. So this is where we have point R. So since this is what we have, you can always connect to get a triangle. So the distance here is 13 kilometers as given in the question. So now, this is a triangle. We are going to make this information complete so that we can calculate correct to the nearest kilometer, the distance PR. That is this distance here. So if you look at the diagram, if this angle is 65, there is a relationship between this angle and this other angle here. What is the relationship between the two angles? The two angles are said to be what? alternate. So if this angle is 65, this one also must be what? 65. The bearing from the north here to this line is 146. So I want to know the remaining part of the angle here. And we know that from this line, from the north to the south, the measurement is 180. So what is 180 minus 146? That will give us 34. So if you add 65 plus 34 will give us 99 degrees. So we are asked to calculate this distance, and I'm going to label this side as small letter q, kilometers. This is our diagram. So the diagram we have is completed, and this answers question Roman 1, which says sketch the diagram of his movement. Roman 2, calculate correct to the nearest kilometer the distance PR. Can we do that here? So the distance PR is already labeled as Q, kilometers. So here, to get this answer, I refer you back again to the previous lesson. You learn about the cosine rule. All right? Now, in the cosine rule, we are going to use the letter here given as Q with the other respective letters to solve, not in the case of how it was given to you by your teacher in the previous class. So, assuming the triangle is labeled PQR, so those are the letters that we are going to use. Okay? Not necessarily using A, B, C, D like you did in the previous lesson, because the letters might change. So here, this is the side we are calculating. You can use Q square is equals to, we have the sides, this side will be P and this side will be R. So it's going to be P square plus R square minus 2PR cos, the angle at Q is known, so we set cos Q. So this is the cosine rule that we're going to take to help us calculate the length PR. So we move ahead. Q square is not known, equals to side P is given as 13 square plus side R is given as 6 square minus 2PR means 2 times 13 times 6 cos the angle at Q is 99. Now, if you substitute in the values, the next thing you do is to simplify. So Q square equals to 13 squared is 169 plus 6 squared is 36 minus 2 times 13 is 26. 26 times 6 will give you 156 cos 99. Now, if you add 169 plus 36 will give you 205 minus 156 times cos 99 will give us negative 24.4038. That is, if you this is exactly what you are going to have, where this negative is there. So if you operate these two negative signs, you will have Q square equals to 205 plus, because it's double negative, 24.4038. Now, what is 205 plus 24.4038? Q square will be equals to, if you add this, that will give us 229.4038. Now remember, the Q is having a square. We are going to take the square root of both sides, where the square will cancel the root. Q equals to the square root of 229.4038 will give us 15.146 kilometers. Remember, we are asked to give the answer correct to the nearest kilometer. So distance PR is going to be equals to 15 kilometers correct to the nearest kilometer. That's the question. So this is the answer to the question. I think I will give you this question as a try before I will leave you. So try this question at home so that when we come back in the next lesson, we can solve it. The question is, an aeroplane flew from town A 200 kilometers to town B on a bearing of 135 degrees. It then flies 250 kilometers from town B to town C on a bearing of 45 degrees. Find Roman 1, the distance of A from C. Roman 2, the bearing of A from C. So these are two messages. I'll repeat it for you. An aeroplane flew from town A 200 kilometers to town B on a bearing of 135 degrees. It then flies 250 kilometers from town B to town C on a bearing of 45 degrees. Find Roman 1, the distance of A from C. Roman 2, the bearing of A from C. This brings us to the end of today's lesson. Please don't forget to follow the advice of the medical workers. Stay safe. Wash your hands with clean running water. If possible, use hand sanitizers all the time. And then avoid crowded places. On that note, I thank you all for watching and listening.